Okay, this lesson is 1.3, Linear Functions, Slope, and Applications. And so most of you are pretty familiar with lines. And our definition just says that linear functions can be written of the form f of x equals mx plus b. Most of y'all think of y equals mx plus b, but we're using function notation. M and b are constants, meaning they're numbers. Okay, a couple of things. One is that if m is 1 and b is 0, think about what that would look like, you get the identity function, which is just f of x equals x. And what that looks like, that would just be your perfect diagonal line. Okay. And then if m equals 0, the function is called a constant function, and that would look just like f of x equals b. And that would be a horizontal line that would go through all the points where the y value is whatever that b is. And we'll talk more about that in just a second. Slope is your vertical change over your horizontal change. A lot of you know it as rise over run, but you also have this lovely formula, the slope formula, that can help you when you have 2 points that you're trying to determine the slope between them. Something to know about slope is when you get a positive number, that is an uphill slanted line. A negative number is a downhill slanted line. And that's, again, with your slope. And the bigger the number, the steeper the line. Okay. The bigger the negative number, okay, so like if this was -1, a -3 would be steeper. Okay. That's how the slope works. You guys know what I was just talking about, the form of the line, f of x equals mx plus b or y equals mx plus b. That is slope-intercept form of a line. Slope-intercept form of a line, in case that's brought up. Okay, now we're going to talk about horizontal and vertical lines. These are our special cases. And horizontal lines, think of the horizon. It's your flat line that goes like this. And as I mentioned up there, that is your identity. So your equation might look like y equals a number or f of x equals a number. That's how you know it's a horizontal line that you're graphing. These are functions. They pass the vertical line test. So if you're asked if a horizontal line is a function, yes, it is a function. The slope of this line is 0. If you had 2 points on this line and you did the slope formula, you're going to get an answer of 0. And that makes sense. It's not slanted any. It's not uphill or downhill. And so a 0 slope, meaning that it's flat, kind of makes sense. Vertical lines are your straight up and down lines. And the equation for that looks like x equals a number. So if you get x equals 5, that's a vertical line at 5. These are not functions because they fail the vertical line test horribly, because every single point is hit by the same vertical line if you were to lay a vertical line on top of it. And so it's definitely not a function. The slope of it is considered undefined. And if you work that slope formula out with some points, you get the 0 on the bottom of the fraction when you're working it. And again, that is your clue to think that it's undefined, because 0 on the bottom of a fraction means undefined. All right, let's come down here, do some examples. Okay, so we have an example here where they're just wanting to graph this function and determine its slope. So I can look at this. I know that the number in front of the x is the m, that's the slope. So the -2/3 is the slope. I'm going to go ahead and write that down. The 1 is the y-intercept, in case they ask about that. So here, if you want to graph it, you start with the y-intercept on your y-axis. So I'm going to start by plotting a point at 1, and then I'm going to use my slope. It's going to tell me to go down 2 and over 3. So down 2 and right 3 from the point I just made. So 1, 2 would put us at -1, and then right 3. And then I'm going to try to draw the best line I can through those. And there's my graph. All right, number 2, I have 1/2 x plus 4. So let me put some labels here. I have a y-intercept of 4, so I'm going to go ahead and plot that. There's my point. And then my slope is 1/2. That means because it's positive, I'm going to go up. So I'm going to go up 1 and right 2. So from the 4 that disappeared, I'm going to go up 1 and right 2. And there's my line. And hopefully everybody's familiar with doing that. Okay, 3 and A and B is like our special cases to look at those. So x equals 2, if you remember, that is your vertical line. X equals -2. So you go to where x equals -2 on the x-axis, and you draw a vertical line through that. It's very easy. And if you remember, we're asking for the slope here, and the slope of a vertical line is undefined. So I can say slope undefined. B, I don't have any x's, just y equals a number. That is your clue that it's a horizontal line. And so 5/2 is about 2.5. So right in here, I'm going to do my horizontal line. And the slope of that is 0. So that's our two special cases. Your vertical line, x equals a number. Your horizontal line, y equals a number. All right, number 4, find the slope and the y-intercept of the line with this equation. And so this is just being able to look at that and know what the m and b are and what they stand for. So our slope, m, is that number in front of x, but not including the x. So -0.25 is our slope. Our y-intercept is the number that's by itself over here, and it does include the negative in front of it if you have a negative. So our b, our y-intercept, is -3.8. All right, 5, it asks us to find the slope and the y-intercept of an equation, but it's not in y equals mx plus b. It's not in slope-intercept form. So you have to get it there. I'm going to subtract the 3x and add the 7 to the other side to get rid of those. So they're going to go away here. And I'm going to get -3x plus 7 on the right. But I'm still not done because I just need y by itself. So I'm going to divide by -6. And it's going to cancel out over here. That's going to give me y equals the -3 over -6 is going to reduce to 1/2. And then the 7 over 6, I'm just going to leave that as a fraction, but it's negative because the 6 was negative. So I'm going to say -7/6. Now I can tell that my slope is 1/2 and my y-intercept is a -7/6. Now to the applications of slope, which is another word for we have some word problems. The main application that your textbook wants you to know is about the grade of a road or a ramp. I'm sure you've seen the signs on the side of the highway if you're going to Asheville or Boone that give the percent of the incline of the road, and that's just to let those truck drivers know, how steep it's going to get. So this one says the grade of a road, a number that represents the steepness of the hill or mountain. And again, we're pretty familiar with those around here. So an example is that a 4% grade means that the road is going to rise or fall 4 feet for every horizontal distance of 100 feet. So if you horizontally went 100 feet, the road would rise 4 feet. And they're getting the 4 over 100 to get that 4% grade. Because if you type this in your calculator, you're going to get 0.04, which is 4% when you change from a decimal to a percent. All right, number 6. Here's our application of that. Guidelines for the grade of a wheelchair ramp suggest between 5.9% and 8.3%, and law also states that a vertical rise of 1 foot requires a horizontal run of at least 12 feet, so 12 feet or more. And find the grade of this ramp. Okay, now that I have my given numbers on, they will tell you your rise and your run. We want to figure out what percentage this is. So just like I was talking about up here, just put your rise over your run like you would with slope. So 3 over 42. and that's the same thing as 1/14. So if you type that in your calculator, you're going to get 0.071, which is 7.1%. So it's a 7.1% grade, and it falls within what they suggest for the guidelines there. So that seems like it works. All right, number 7. We have the number of people participating in the Federal Supplemental Nutrition Assistance Program has increased from 17.2 million in 2000 to 47.6 million in 2013. That's huge. The following graph illustrates this upward trend, and if you want to see this graph, it is located in your textbook on page 37. But you don't have to have it because they give us all the information we need in the words. So I didn't try to get it in here. Find the average rate of change in the number of people using food stamps from 2000 to 2013. And so you can look at these like 2 points. They give us the information for 2000. So in the year 2000, there was 17.2. And then in the year 2013, there was 47.6. So I can view those like 2 points, and those points are listed on that graph. And we're just finding the slope because slope is average rate of change. So I'm going to do y minus y over x minus x. And that is going to give me 30.4 over 13, which is a slope of 2.3. And so that means that the people participating increased an average of 2.3 million per year. Okay, for our example 8, they're talking about oil, and it says there's an increased oil production in the U.S. has resulted in decreased imports of crude oil, because if we're making it, we don't have to get it from somewhere else. The total number of barrels imported in 2008 was 3,590,000. This number had decreased to 2,810,000 barrels in 2013. Find the average rate of, that's supposed to be change, in crude oil imports from 2008 to 2013. So again, I want to look at these as points, and I have the point 2008, 3,590,000, and I have the point 2013, 2,810,000. And so I'm just going to go ahead, since average rate of change is slope, I'm going to find my slope. And some large numbers to work with. But I'm doing y minus y over x minus x. Okay, so I'm going to let my calculator do the heavy lifting on this one. And we're going to come up with a negative 156,000. So it's decreasing by about by about 156,000 barrels per year. So anytime that you calculate a slope, think about the units that are on top, that's our barrels, and the units on the bottom are years. So you can come up with the units on your answer just by thinking of barrels over years. So barrels per year, if you need to know that, makes it pretty easy. All right, our last example is pretty long but interesting. There's no way to prove, no proven way to predict a child's adult height, but a linear function can be used to estimate it. And so if you take the sum of the child's parents in this, given that sum, so the adult height m of a male child whose parents' combined height is x can be estimated by this function. So this is saying if you have a boy and you add the mother and father's heights together, that's your x. So if you put their height in, you can predict the boy's height. They also give us one for females. So if you have a girl, and again, x is the male and female height in inches added together, we can predict the female height. Okay, so the question becomes, they want us to estimate the height of a female child, so it's the second one, whose parents' combined height is 135 inches. And then we need to discuss the domain of that. So 135 inches, we're going to plug that in. F of 135 would be 0.5 times 135 minus 2.5. And that would give us 65 inches, which is 5 feet and 5 inches, if you're wanting to know that. Now, let's think about the domain. This equation is a line, and if you think about the graph of a line, you think of the domain as being all real numbers. But for heights, it doesn't make sense. Technically, obviously, if you have a person, 0 height, it would have to be above that. So 0 would be the lowest. And, you know, heights vary, and there's some strange tall people out there. But a realistic height, you know, the highest we might get, we'll say, is 110 inches. Or if that's what your book suggests. So we're really not going to go with 0 because I don't know any adults that are like half an inch tall. Your book suggests using a interval between 100 and 110, and I'm assuming that's where like the majority of adults fall, between 110 inches and 100 inches. But you want to think about realistic domains. Even though the domain, again, of this line would technically be all real numbers, they're probably going to ask you about realistic answers as well. All right, thank you.